Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday at the playground, this little girl suddenly asked me to explain this question to her. So in this question, we have a cart which is attached to a spring, which is attached to this oscillator. When this oscillator is jiggling the spring left and right, the cart also goes into simple harmonic motion. And we're provided with the graph that shows how the amplitude of the forced oscillation varies with the frequency of the driving force. So what happens when we attach a light cardboard onto the cart? So when the question says light cardboard, it means that the mass of the cart is not affected, which means the resonant frequency of the cart is not affected. So the resonance is still going to occur at the same frequency as before. So what does this cardboard do? It increases the amount of damping because now you catch more wind, right? So with larger air resistance, the amount of damping is higher. Since the amount of damping is higher, at resonance, the amplitude will not be that high. It will be lower. And the larger amount of damping happens at every other frequency as well. That's why if you were asked to sketch the new resonance graph, you have to draw a graph where every point is lower than before. Every point is lower than before. Every point is lower than before. Except here, where the driving frequency is close to zero. Because when the frequency is zero, it basically means that you're moving at a very slow speed. So having the cardboard or not, it doesn't make any significant difference. That's why at f equals to 0 is the only point where the two resonance graphs has the same amplitude. In fact, this amplitude is just the amplitude of the driver, yeah? Because at very low frequency, basically the cart tracks the exact motion of the vibrator. Okay, in the next scenario, we are told that we are going to add a mass to the cart. So please don't say that adding this mass is going to increase the amount of air resistance encountered by the cart. I think we can always assume that this mass is not going to be so bulky that it catches so much wind that air resistance becomes significantly affected. So what is the significance of having this additional mass here? Well, we know the natural frequency of a spring mass system depends on the stiffness of the spring and the inertia of the system. So when you have a larger mass, the natural frequency is going to be lower, which means resonance is not going to occur at the same frequency as before. It's going to occur at a lower frequency. That's why if you're asked to sketch the new resonance graph, you have to draw one where the resonance peaks at the lower frequency. So instead of peaking at this frequency, you're going to show that it peaks at a lower frequency. But is the resonance going to have a higher or lower amplitude than before? Well, that's beyond the A-level syllabus, so we don't care as long as you show that the resonant frequency has decreased. I hope this little girl will continue to study physics. I think she's very talented. Ta-ta!